Hey guys, welcome to the channel. We're going to be solving question 56 from the second chapter of Hibbeler textbook. Alright, so we know that the magnitude of the resultant force acting on the bracket is 450 newtons directed along the positive u-axis. So we can see the u-axis in here. And the resultant of these three forces, which we can show it with Fr, is along the positive side of the u-axis. So we're going to call it Fr. And we need to determine the magnitude of F1 and its direction phi. So we have two unknowns in here, f1 and phi, which is the angle of f1 with the y-axis. And for doing that, we're going to break down each of these forces into x and y components. And since we have Fr and we know Fr makes 30 degrees with x-axis, we can find the x and y component of Fr. So let's start with that so we can find the x component of Fr. I'm going to show the x and y component of Fr. This will be the Frx and this will be our Fry. So Frx in here would be cosine of 30 degrees. So we'll have Fr times cosine of 30 degrees. We know Fr from the question is 450 Newton. So 450 times cosine of 30 degrees. And if we calculate that, 450 times cosine of 30, that's going to give us 389.71. And if we want to find Fry, this time we have Fr sine of 30 degrees, and both components are in positive direction of x and y, so they're both positive. This time we have 450 times sine of 30 degrees. We know sine of 30 is 0.5, so basically we have 450 divided by 2, which is 225. So Frx would be sum of all forces in x direction, which is the x component of F1. And if we look at it, we'll see that the x component of, I'm going to clean up the figure, we can see it better. So if we want to show the x and y component of F1, this is our F1. This will be the y component, F1y, and this will be the F1x. They're both positive, so we have the x component of F1, which will be F1 times sine of phi, which is one of the unknowns that we have. And actually, we have the same scenario for Fry2. This time we have sum of all forces in y direction. And if you want to find the y component of F1, it will be F1 cosine of phi. So keep in mind that fx is not always f cosine of the angle that we have. We have a condition. If we have the angle with x-axis, that's correct. F1 would be f1 cosine of that angle with x-axis. And since here our phi is the angle between f1 and y, that's why the fx is f1 sine of phi. So always go with the definition of sine and cosine, and fx is not always cosine. It can be sine if we have the angle with y-axis. So that's pretty much everything for f1. If you look at f2, we'll see that f2 is along the x-axis, so we only have x component for that. So plus 200 and no y component. And the last one is f3. I'm gonna show that with different color again. This will be f3y component and this will be f3x component. We can see that the x component is actually positive, but fy is downward, which means we have a negative sign for y, but fx is positive. So here we need some information in here in order to find the fx and fy. So if you call this angle alpha, this angle here would be alpha 2. So the horizontal component would be sine of alpha, which is 5 over 13. So 5 over 13 times 260, and the y component, which is negative. This time we'll have cosine of alpha, which is 12 or adjacent over hypotenuse or 13, and this will be 260 as well. So the top part would be equal to Frx, which we found 389.71 in the previous step, and the sum of all forces in y component would be equal to Fry, which is 225 newtons. So we can cancel out 13 and 216 here. It's going to give us 20. So from the first equation, we have F1 sine of phi plus 200 plus 100 is equal to 389.71 So that shows F1 sine of phi is equal to, this will be 300, 389.71 minus 300 is going to be 89.71. So that was from this equation, and from the second one, we're going to get F1 cosine of phi. And the same thing, 20 is equal to 225 plus 12 times 20, which is 240, or 465. So let's just divide the first equation by the second one. If we do that, we have F1 sine of phi over F1 cosine of phi is equal to 89.71 over 465. And on the left side, we can cancel out the F1, and we have sine of phi over cosine of phi, which will be the tangent of phi. So our phi in here would be tangent inverse of 89.71 over 465. Let's figure this out. So 89.75 divided by 465, that's going to give us 10.92 degrees. That would be the first unknown in here, and we can use one of this equation in order to find the F1. Let's take the first one. F1 would be 89.71 divided by sine of 10.92 degrees. So 89.71 divided by sine of 10.92. So our F1 would be 473.56 newtons, which would be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. We're covering 3 different textbooks in this channel. Feel free to let me know if you have any specific problem from these textbooks that you want me to cover in the next videos. And you guys take care. I'll see you in the next one.